So last we are looking at the operators, right? Commonly used operators, and I think last was the ternary operator here, right? So any questions on operators? Uh, one of them I think was that instance of thing, right? Okay, one of the operators was instance of, yeah. Any questions are there? Okay, fine. Okay, just quick review. I think we can just go back and see what was done. Okay. Ternary operator was, I think that's fine, right? Yeah. How it works. Okay. Okay. One was the lambda operator. Yeah. Okay. Yeah. This actually requires that you may have to know about interfaces. Okay. But yes, if you already know about Java earlier, you would have known interfaces. Okay. There are some changes which have come in interfaces from Java 8. Okay. And because of which, yes, we were able to use a static method in interface. We were able to use a public static void main, right, in an interface. Okay. Uh, so that's one thing. Okay. So yeah. Other operators, I think, other than this yeah, so interface had another type of interface, like classification of interface was done, and we have a concept of a functional interface. Yeah. Fine. So when we look at interfaces, that time, yes, we'll come across that, and that time we'll again look at what is lambda and what is lambda expression, what it is about. Okay. And yeah, instance of, yes, any questions here? Yeah. Anyone else? Yes. Okay, date and time. Maybe I took a wrong example. Okay, if it was like car and sports car, maybe that may have been a better case. Okay. Yeah, I think we had started with this, right? Okay. Okay, fine. Maybe we'll come across that instance of thing again, and we'll revise that later also. Okay, so let's proceed and let's look at the statements in Java. And we have seen most of the operators. There might be a few other operators, okay, but I think most commonly used operators, which we know from C. Okay. So that we have seen, and now let's proceed with looking at the statements available in Java. Again, these are, most of them are same as what we have in C language, okay, but still we'll list them and find some comparisons if they are different from C language, how they differ, that we'll check. Okay. Okay. So statements in Java, yes, we have the conditional statement. Yeah, what is the conditional statement? Yeah, which are the conditional statements which use a condition? Yeah, first one. if statement, right? Okay, fine. So if, and then uh, if else. Okay, the conditional yeah, first just this one. Okay, if and if else, right? Okay, so for if, we know this if and then. For Java it has to be a Boolean expression only. Okay, fine. So it has to be in bracket, and then maybe single statement, or you have a block of statements. Okay, and we understand if may again have a else. Okay, and again else also has its. So that this is one construct we have. We use this also in another way, where we say we'll use something like this: if else, and in the else we might again put a if. Okay, and this can again be having another else if, else if, else. See, what is that structure like? If else if structure, right? So this is your condition one, right? If condition one is this, if it meets the condition one, oh, this is to be done. Else, if it meets the condition two, this is to be done. Else, so when you are writing a if else if structure, you are actually testing one by one conditions. Okay, and maybe the last you may keep a else. So if it doesn't meet all of these, we have a else part. Okay? So this kind of a structure for certain types. And if you are just testing a value, okay, we have another kind of a statement, right? This is if and if else if. Fine, we are familiar with that, right, in C language. Okay, so yeah, so other than this if else if kind of a structure, okay, I should put here a condition, right? Okay, okay. So yeah, what's the other statement which also is more like a conditional thing? And for is for iteration, right? So yeah, we categorize in iteration, which is again conditional, right? And more similar to the if else if structure. Switch. Okay, when we have the switch case, then we say switch case. Yeah. So yeah, how does a switch case work? Okay. So here from C language, yes, when we say switch, what do we get? In brackets, we have to specify some expression. Okay. Not Boolean expression. Okay. This has to be a expression. That expression will be of type. Okay. And okay, we have an expression and we have the body of the switch. Okay. We'll see what goes in the body of the switch. But one thing about the expression is, okay, what we know so far. Okay, from C language, what we know is this expression can be a int. You can't keep a long here, right? If I'm saying int, it covers the char, right? Okay, that was in C language, right? So in Java, it can be a int, or it can be a, no, not long. It can be a string. String from Java 7. Okay, from Java 5, it can be enum type. And if you have defined a enum means a class with fixed number of objects. Okay, it's just like a class where the objects are fixed. Okay, for this class only these objects. So there are known number of objects, and therefore you can use with in as a expression in the switch. Your switch expression can be of the enum type. Okay, for example, you might have a enum. Okay, we may have a enum. Let's say, okay, so we may have a enum for the month, right? If there is enum for the month, yes, you might have January and February and those kinds of things, right? Okay, fine. So you may have defined some kind of a enum called month. So someone could write like this: I have a month expression. So I have something month m as a variable equals. We don't know what is assigned here, but one of those objects only, nothing else. Okay, and then if someone says switch, yes, we can use switch for m. Okay, and when we write the case, yes, we want to write the case for January, right? Yeah. Oh, when we write a case, what do we normally write? How do we write it as colon? Right? It's nothing but a value and colon, right? That's how we put it. Okay, and case value colon. Okay, and then we can have another case. Yeah, and we have some statements here. Okay, right. Then after this, maybe someone says, "Oh, I want to put March first." Okay, that's fine. Okay, you have statements 1, you have statements 2, another set of statements. You can write a default, put a colon. Okay, you got some statements 3. Okay, okay, fine. Suppose you write like this here. So what will happen if the month happens to be March? Okay, let me also put one more thing here to clarify that you could be writing case after a default also. Okay. And normally, yes, we have a habit of putting fine default at the end. Yes, so you may have something like this. Okay, so what statements would be considered for execution if that m happens to be March? Right? If the value of m happens to be March, what statement should be executed? Statement 2, 3, and 4. Okay. We need the, so when we write switch like this, we are, and if you forget this, right, we have this problem, right? We may forget this. Okay, we may forget to write a break. See, unless you put a break, right? Okay, so if you don't put a break, we know it will be going, it just falls through. See, many times we refer to this as a conditional go-to statement. It's a conditional go-to. Depending on the value, it is like a go-to. Fine. So, oh, depending on the value, go to that place and then keep on executing from that point onwards. It's a go-to within the block of the switch. Okay, if it encounters a break, come out of the switch. Fine. So break is for, yes, so you for some reasons, if you have, maybe you might like to not put a break, something to be done incrementally from this point onwards. Okay, that could be a requirement. So yeah, you can have without break also, fine. You might have a case, but the subsequent case is, so if you jump to this place, okay, I would like it to do everything below this. Maybe you have arranged them in that manner. Okay. Fine. So a switch case, this is what is in C also. Only thing here different is, yes, oh, we have been able to use int values. Fine. The expression here in the switch expression can be a int type. It can be string also, right? From Java 7 we can have string. Java 5 provided enums where we had fixed number of objects, so you could also be using a enum type. Okay, fine. Now what happened was, yes, there is a revision on how the switch is used. Okay, some more, this will work. It is, all features are always going to be backward compatible. And so Java makes changes, but they keep backward compatibility, or your old code, the old style, that should still work. Okay, so one thing was, it's not very, it's almost always that you will have a break, and you'll be writing a break all the time, and so you want to compartmentalize it. Okay, fine. So yes, yesterday we saw one operator, which was the lambda operator. Okay, fine. Not as a lambda operator, but it is reused. That same thing is reused here. Okay, how it has been reused is, instead of a colon, okay, if you use that, right, if you use this, you can write like this. You don't need a break. Then you don't need a break. But yes, it's either you use everywhere this arrow, okay, or use colon. So stick to one of them. So you can't say, oh, at one place I'll keep this, other place I'll keep a colon. Okay, it has to replace everywhere, even the default thing. Then no break needed. And it's okay for this case. That's a statement one, and that's a set of statements. Yes. We use instead of break. So we don't need the break now. Okay. So yeah, so it has to execute this in case it is January. Only this. It's not going to fall through. When we use colon, it's like a jump from that point onwards, right? Go to this and proceed. Okay. If you encounter a break, come out. And so depending on the value, go to, okay, depending on the value, go to the appropriate place. If you don't come across a value, which if this value, if you don't have a case which matches, jump to a default. If there's no default, okay, come out. Fine. Okay, fine. So some changes which have come, and from Java 12 or 14, somewhere around that, switch the topic, if you look for, we have something called switch expressions. It's coming with switch expressions. So it's not only it's a much bigger change than just about, okay, switch case. Oh, that we don't need a break. That's one thing. So many times we would be forgetting to put break, right? Okay, so yeah, start using this. That's one option. Okay, fine. Another thing which has been done is, you can combine multiple values in one case by putting a comma. Okay, fine. So case January, comma, okay, maybe for January and March, yeah. See the number of days, for example, yeah, January, March, and then What will it? Yeah, May. Okay. Yeah, we are using 3 letters. Yeah. Okay. So for all these cases, yeah. What's my statement? Okay. So we have month M, and we declare int. Okay. Days equal to 0 or something like that, maybe. So you just declared it, right? And then here, what we are trying to do? Yeah. What we'll do? Days equal to 31. Okay. And in case it is okay, February, then days equals 28 or 29 as okay, maybe we can give 28. Default days equal to 30. Yeah, it's an assignment. And okay, and maybe something like this. Okay, so we may do something like this, right? So multiple values, right? What is shown is yes, in a case you might keep multiple values. Okay. Now, what is also allowed? Okay, this because now we are talking about switch expression. We understand what is an expression? Results in a value, something which can give me a value. Fine. So we can make this into an expression also. And this can be turned into a expression. For example, what we do here is okay. So okay, we don't put a statement, right? This, yeah. You can just say, oh, this is 31. It's an expression, right? 31 is an expression. Yes. So this is an int expression. And I could have done like this, equal to, and this one. Yeah. It's the switch statement. This is an expression because what we are having here is an expression. Uh, the expression here is just a fixed constant value, but yes, it's some kind of an expression. So you can have expressions coming here. So this is switch expression. Okay, fine. So it's like this. Oh, normally, yeah, we put it in this line itself, maybe 31 here, right? Fine. So case all this 31. It's like saying the result of the switch is 31 in case. So switch is an expression now. You can use switch as an expression. You can have switch as a statement also. If you are writing statement, it's fine. And if you are putting some statements, okay, so that's a statement it will execute, but then it is not having a value. You can't then be assigning to it.
When was this introduced?
I'm not sure. It is either 12 or 14, somewhere around. But 14, by 14 it was there. You can check that. So, but yes. So we have something called switch expression. This went through multiple iterations. Like there were 2-3 times the review was done. Preview was given for this. So it was a preview feature. But I think from 14 at least it has come into the system, like main feature.
It makes it more concise. The coding becomes concise.
Yes. Okay, fine. So not only this, there's something, okay, here I am giving an expression straight away, right? Arrow and put an expression. But now uh, I have to give you an expression. I want to, this is a switch expression. The switch must have a value. For each case, I must be capable of giving a value, but I can't give you the value straight away. It's not, it may not be as simple as this. It may involve a computation. Okay, maybe for example, in case of February, right? Okay, for Feb, it may not be possible for me to finish as a single expression like this. I might like to have a mechanism, fine, where I'll say, okay, so test for, maybe I again want to write some kind of if statement. If and test for leap year. Okay, so some test for leap year. If it's leap year, okay, then I want to return. Oh, is it return? I want this to be equivalent of, it should be 29. Okay, else it should be 28. Oh, we can't write like this. This is not possible. Okay, you're writing a if statement. How can if be just saying, oh, the value is 29? In a fine, it has to be a proper statement. 29 is not a statement. It may not always be possible, right? Maybe it's not about writing a if statement. You need some more statements. The idea is you need some more statements before you can determine the value for the switch. See, it's about what is the value of the switch. What value for the switch should be made available. Okay, so we have a contextual keyword being used here. Okay, there is a contextual keyword called yield. So we'll say, oh, yield 29. Okay, so that's the correct way of doing it. Okay, yield 28. Fine. Anywhere, yes, you can put the yield statement. So yield is nothing but a like a statement. Now it's a statement. Fine. Fine. Don't be using return. Return has a different meaning altogether. What is return?
Return is used in the context of function.
Yeah. Return means give the value to the function. See, the statement appears inside a method. That method has a return type. If you write a return, it has to do with that return type of the method. Okay.
Switch is not a function.
Yeah, here it's just an expression. But one thing about switch expressions is when we use switch expressions, a default is mandatory. The default is mandatory because you, whatever values you are trying to cover, it may not be sufficiently covering everything. Okay, see, if I'm using a int type here with enum type, if you have covered all the cases, default may not be required. If you have covered all the cases, default may not be required. Okay, fine. There are two ways of using switch. Switch as a statement, which was the case earlier, and switch as a expression. When it is an expression, within the body of the case, there has to be a value. Okay, it has to yield a value. And we'll say it has to yield a value. Fine. So there is that statement called yield. Fine.
We have to write values in we use here.
Okay, this becomes a expression. I want it to be a something which is a value. The switch is resulting in a value. Switch is simply a statement the way it was earlier. So it's fine. See, if I was using that earlier thing, uh, I would have put a break, and I won't have been putting a value like this. I won't be allowed to put a value. I can still do see. Uh, there are two aspects. I think see, there are multiple things which have happened, and a lot of changes if you look at the switch itself. Okay, multiple changes, and go over them one by one. Start with the conventional switch. Let's see. So if it is a conventional switch, we were only using colon, fine, and that required break. It was not compartmentalized. Right? Each case was not compartmentalized. A break was necessary to create a compartment. Okay, multiple cases fall in one compartment. That could be possible. Right? That was there. Okay, so that thing still persists. When we use colon, we are not compartmentalizing. A break would be required. Break would be required if you want to compartmentalize. When you don't want to compartmentalize, okay, don't put a break. Fine. One aspect. Second, and so fine. So fine. That was the original one, right? Just the colon, and we start with that. Next change, multiple values. For a case, we can put multiple values. This wasn't possible earlier. Okay, separate by comma. So for all these values, I want to do this. Okay, with colon also. What's the difference between colon and the arrow? What is the difference?
Arrow introduces break automatically.
Okay, fine. If it's arrow, automatically compartments for each case. Fine, compartment, right? And this case, oh, that's my compartment, right? So put an arrow, it's only referring to this. It's never going to fall through. It doesn't matter if any of these values, it doesn't look at anything beyond this. Okay. Fine. So difference between colon and arrow is about that, right? Another thing would be about, so okay, so still let's say we are keeping it as a statement, right? So we are having switch as a statement, but someone wants to say no, I want the switch to result in a value. If you want it to result in a value, only thing you have to do is each place must yield a value. Each compartment yields a value if it's compartmentalized. If it is not compartmentalized, you could still be using a colon here. Fine. But if you put a colon here, you can't say 31, you'll have to say yield 31. Okay, you'll have to write one is yield has to be returned. Okay, then the switch has a value. And then if it is have a value type, yes, you could be assigning. And you can assign. Right? See, here instead of 31, what was the case? Oh, we were saying in days was a declaration and saying day is equal to so and so, day is equal to this, day is equal to, and everywhere we are saying making a assignment statement. It's not only because in our case we have put an assignment statement, but it could have been something, some other valid statements which you may be carrying out, and multiple statements, right? So Here also, right, I can put a colon, I can put multiple statements, and then I'll have to say yield. With arrow also, you have statements, but you'll have to put a block, fine, and then you'll have to say yield. If it's multiple things. If it's a single value, fine, you don't need to execute some statements to derive the value, then straight away the value can be specified, or any expression may be specified. Okay, what will be the type of the switch? What is the type of the expression for the switch? It will depend on the expressions for the yield. Okay, this you can consider, though I don't put a yield statement, this can be considered as a yield. Okay, I'm just putting a value here, right? So this is yield. So all the yields, just look at all the yields, which is the super type which can cover all the yields. That's the type of the expression. Somewhere I'm yielding a int type, somewhere I'm yielding a double type. Fine. If there is a yield, it's an expression. The type of the expression is whatever is the supermost type for which can cover all the yields. Okay. Fine, you can use them anyway. If you want, you can just try this month thing also, right? But for that, yes, you'll have to define an enum month, which can be done very easily like this, right? Enum month, and just put like this. That's it. Okay. You want to have a value being assigned to this. Okay. So anyway, we have not yet covered anything about enum, except for knowing that yes, it is nothing but a list. It has a list of objects, fixed number of objects. So you could be doing something like this here. Okay, so that's how you can assign a value, month dot, and keep any of the enum names. Those are the enum names. Okay, names of the objects. So you can put the name of the object. Okay. Anyway, later we will be defining our own enum also, okay? And we'll be using the enums. Okay. And there are examples. We will definitely be using more 2-3 different enums as we go along. Okay, we'll be creating our own. Okay. And there are a lot many enums already there in the Java library also, and which are useful. Okay. Fine. Switch. Clear about switch? Okay. Always remember about if it's a switch expression, you will be providing a default. Only in case of the enum type, if cases are covering all the enums, then default is not necessary. See why default is a must? Because this has to have a value. Fine. If this was not a month type, it was an int type, let's say. Okay. Depending on the int, I might be yielding some strings. Okay. So so if some string which is provided happens to be not available, fine, it is not covered by the cases, then what is the value it should represent? It has to have a value. See, when it was not the expression type, it was just a statement. It was about executing those statements and nothing about yielding a value. But when you are saying, oh, it needs to yield a value, right? So it would be a compilation error for a switch expression, which is not for the enum type. Fine, enum type covering all the cases is where default is not necessary. If you don't put a default, it would be a compilation error. The compiler will say, oh, that's an error.
It will say that statement is cannot be.
Yes, you have not put a default.
Unreachable.
No, not unreachable. The default is missing. There's no unreachable because you have the cases, but what about the case which is, what about a value of the expression for which the case is not provided? Suppose instead of, yeah, in this example, suppose in this example, okay, then in this example, if I am taking, I don't put a default, okay, but I try to list them, okay. I'm not putting a default, but I'm trying to list them, but I miss out some name. I miss out a month, and suppose that happens to be that month value, right? In that case, there's no place where it can reach in this. It's not. So how does it get a value for that case? It needs a value. So these statements, whatever are there, they are reachable. It's not that they are unreachable. But a case is not getting covered. For a case, I don't know. I don't have a statement. I don't have a value basically. Okay. So default for, if it's an int type, we can't be covering all the ints, the cases for all the int types. Okay, string type here. So fine, we know this, right? Our expression here can be of type. What can it be? Yeah, int, string, and enum. Okay, fine. There are some preview features, so they are not mainstream features for what can be done here. There are more things being added to switch. Okay, we call it as pattern matching for switch. Okay, switch expressions can also use pattern matching. There's a pattern matching. Pattern matching involves the instance of. And yesterday we were looking at that instance of. So pattern matching involves instance of. So yeah, we may have to take it up later. Right? So once we have we reach a particular level, we'll be able to understand what is that pattern matching. Okay. Pattern matching, any instance of what we were doing yesterday, and pattern matching is applicable there. And we'll try it with our actual examples. These are some small features which keep on getting added. Some modifications came, and that has been so. That's like, because Java now is a new version of Java every 6 months. Okay, we have got a new version of Java every 6 months. Okay, so mid September, yeah, mid September and mid March. Okay, somewhere around 15th, plus minus here and there, right? Okay. So that is fixed. The cycle is fixed. 6 months, a new version. So with new version, some new features keep on getting added. Okay, fine. So any questions now on switch expressions? Okay. Okay. So, and this yield is there, and that we should understand now. Yield will be applicable to expressions. So switch as an expression, switch as a statement. Okay. Okay. Yeah. What other statements are there other than the switch case?
For
We have, yeah. So we have the other statements which are, okay. We have a for.
do while
Okay. okay, for, yeah, let's see that. For, okay, there are three where we can use iterations, right? Iterations are three, right? One is for, okay, we have the while loop, and we have the do while. And so all three, yes, we have the same thing as in C language. Okay. In case of a for, okay, there is an additional one, okay, which is giving us a easy way of writing iterations to iterate over some kind of a data structure. For example, the array. You have data structures, yes, you can iterate over elements of a data structure. You give me the elements from a data structure. For example, if we have an array, okay, for example, we had a string array, okay, let me give the variable name as names, okay, right. I'm not writing the old kind of a for loop now, okay, but this for, we call it as a for each loop. The each is not a keyword here, okay, but the loop here is written, referred as a for each loop. Okay. So the for each loop works like this. We'll say, okay, for each, the data structure has elements of type string. The elements in the structure are string, and therefore I'll say for each string, let me give a new variable name which is local to the for each loop. Name in my data structure. What is that data structure? Names. For each string, name in names. And here I'm writing what will be done with each by looking at each and every element. And one thing in this case is you do not know the index value. Normally, when we write we were writing the loop to iterate over elements of an array, we were having the index value for int I equals 0, right? And I less than the length, I plus plus. Okay, you had I to refer to the current index position. Okay, we'll say names of I. Fine. So because you know I, you are able to update the array also. Within the loop, you will be able to update the elements in the array. Here, the elements in the array, you don't know which element it is. You are only given the value one by one, supplying the value one by one. Okay. The name, string name, that local variable, right? That is something which you cannot assign to, and it doesn't make sense to assign to the variable name, and you can't. Okay, it would be a compilation error if someone says name equal to something. You can't be doing this. Okay, right. That would give a compilation error basically. Okay, so because this is, it's like a local variable, each time it comes up, picks up the next element from the array and makes it available through a variable called name. Okay. So iterating over elements of an array, this looks, compared to the earlier way of writing code, this looks simpler. Only thing is, it is much simpler to write this way. You don't have to worry about the indexes and writing it correctly. Anyway, it was almost a standard way of doing it, so everyone was knowing the correct way of using it. But still, yes, this looks cleaner. Okay. Right. So unless it's necessary to be updating the elements in the array, you just want to use the elements in the array. For example, we might be writing a method called find the sum of elements. Okay. Okay. So you have a public method int. Method name is sum. It takes an int array as a parameter. That's a values. Yeah. Or what we might be doing. So we would normally have said, okay, int sum equals 0, right? And then write a for loop. So how do you write the for loop? We're not updating anything in the array. We're just saying int int value in values. Okay. Okay, fine. Yeah, we are not updating the array, right? We don't need the indexes. Okay, fine. So this is our for each loop. Okay, so for each is available from Java 5. Okay. This is working from Java 5. Yeah, if it's a two-dimensional array, yeah, suppose this thing, instead of this, we had a two-dimensional array. Let's say we want to sum up all the elements in a two-dimensional array. So if it was a two-dimensional array, yeah, sum is 0. What will it be? For, oh, what are the elements? Elements are of type array. Right? And then no, it won't be this. You have to again say for each int value in array. Sum plus equal to value. Then the elements in that array are like this. And currently we know about array, and yes, arrays can be used with for each, but this for each is not only about array. Okay, it's not only about array. It works for anything other than the array part, for anything which is, okay, I'll start using the terms. Okay, so anything which is iterable. There is an interface called iterable. Let's not worry about it currently. So the idea being, if you have already used Java and you are familiar with some of the collection things, you might be having something like this list of string or list of something, right? So if you have such things like, oh, I have a list of string, it's a data structure. List is a data structure. Okay, and this could be names again. Okay, equals. Let's not worry about how it is created currently. Then yes, that same loop which we had written earlier, that would work. Okay, we could say for each string name in names. Names is my data structure, but that data structure list is iterable. Okay, list is iterable, and that's why with a list I can, this is a iterable type. Okay, it's a type basically. What type of a type is it? It's of type which is iterable. List is a type. A super type of list is iterable. Okay, so list becomes iterable, and hence it allows me to write like this. Yeah? So you might be saying, we had written that code earlier, system dot out dot println, and we'll just say, oh, we were doing that, right? Hello plus args of I. Oh, we had written the conventional loop. It could have been written with this also. Public static void main and string array args, and then when we were to print, hello to all the names from command line arguments, it could have been written in this manner. Here, for each loop,
Almost all the data structures are iterable. Right? So
Yeah.
it can be applied to all the data
All the data structures, but yes, this is what it is like. It's only thing which is required is iterable. Someone thinks it's not a data structure, maybe it's not in the falling in that category of someone saying data structure, calling it as a data structure, but there is something which says, oh, I'm iterable, okay, fine, use it here.
Even if I have a tree, let's say I have a tree,
Yeah.
that tree can be made iterable.
If it is iterable, okay, you fine, so you need to see the implementation of tree which is iterable. Okay. Clear for each? Okay, fine. So then we have what else? What's the next thing? What are the statements in C language we know about? We have seen the condition statement. In C language, we have a couple of statements. We have another statement called go to. Acha, acha, okay. We didn't discuss the switch and break. Sorry, break and continue. Break and continue. Okay. Java doesn't have a go to statement. C had the go to statement. Okay. Now, let's think of some. We know we can use break in two places, in the context of a switch, also in the context of a loop. Then break the loop, come out of the loop. Okay, what is continue?
It will go back to the
Okay, fine. So it's just some kind of a loop statement which is here, and then okay, so there might be some case if a, there's some variable a, if it has become, so maybe it's of type double, if a equals double dot, if it has become NA and I don't want to proceed further and just break from here. Okay. So there is something which is updating A here, right? It's getting updated, and maybe so A has some initial value, right? So might have double A, or maybe it's a parameter received in the method. Okay, it's a parameter received in the method, and then it's getting updated, and so we know what the break does, right? What it does, from here come out of the break, and the loop is over. If this condition, so normally your break would be in a condition, right? It won't be a straight away, you don't always straight away break it. On a condition you might be coming out. Okay, then you already had a iteration, so iteration was giving its own condition when to come out. So many times it has to iterate, right? But over and above that condition, you have another condition which also should say, okay, it's over. Okay, and similarly, instead of break, if I put a continue, what does it mean? Continue is like saying continue with the next iteration. This iteration is over. Okay, continue next. Just think continue is like saying continue next. The current iteration, stop here, pick up the next. It's not saying come out of the loop. Break was out of the loop. Continue is next, and continue next. Okay, now suppose I have a loop, okay, and I put another loop here. Okay, it's just now it could be any. I'm writing for here just as an example, but these are applicable to the loop statements for, while, and do while, all three. Break and continue are applicable to for, while, and do while. Okay.
Also for the for each loop.
For each. Yeah. Even in for each, yes, some condition you want to break or some condition you want to continue. Okay. Now next thing what we are looking at is, suppose, yeah, so it's just any, I'm just writing some statement maybe, right? You have j plus plus. Okay. Okay. So maybe there are some statements here. Within the for loop, again, there are more statements. Okay, there are more statements. And after this for loop, again, you have, okay, fine. So you got statements, right? A number of statements, and that. So we have this kind of a structuring, let's say, in our
Is it
code.
instead for instead?
It's a
The instead for loop? I mean the
nested loop.
nested.
Yeah. It's a nested loop, right? So this is a nested loop.
So not instead.
Okay, right. So this is fine. Though I have written for, it is any of the loop statements. Fine. Both of them represent any kind of a loop statement. Okay. And now, suppose we have, okay, suppose we have something like this. We have, yeah. So now let's say I have a condition, and here, okay, let's first look at the break thing here. If I put a break, what will it break? Right? That means it's going to go for statement 4. I wanted to break the outer one. We don't have a go to. Right? Based on that condition, I actually want to go for the thing which is like statements 5 here. Okay. So I wanted to break and straight away go for this one. We don't have a go to. How do we do this? So fine. Okay. So now the difference from as far as this break and continue is concerned, for both the statements, we have what we call as a labeled break and a labeled continue. What you can always do is any loop statement or even a switch statement, break is applicable to a switch statement, you may put a label to it. So this is the outer loop. Okay, let me call it as loop 1 colon. That means I have given a label. It could be, loop 1 is just some kind of an identifier. Okay, so any loop statement or a break statement, you might just before that put a label and say, oh, this is loop 2 colon. Right? Maybe there is a few more levels of nesting. Any number of levels of nesting can be there. Right? So when you say break or when you say continue, you can say break loop 1. Or continue loop 1. And we have break and continue. So we can have this continue loop 1. Continue. So if this is the condition, go for the next iteration of the outer loop straight away. Right? You need labels. So we can have labels for our loop statements. We can have label for our switch statement, because break with break is applicable to a switch also. Okay. Fine, clear?
Instead of continue, we using break.
Yeah.
That
Yeah. Okay. So if we have used break, yeah. So if we use the break loop 1, that means straight away statement 5. If it was continue loop 1, here it says continue loop 1. Suppose I was 0, j was 0, and at that time itself we encountered this. Okay, fine. It says continue loop 1. Suppose it says continue loop 1, so it will go back, increment I. Fine. If I just written continue, it would have gone back and incremented j and then proceeded further with the value of I as 0. Right. Whereas now in this case, if I say continue loop 1, it would go back to incrementing the value of I and not incrementing the value of j. Then that's the difference. Continue with which iteration, which loop has to be iterated, and the next iteration should be taken for which loop. More levels of nesting could have been there. Any levels of nesting could have been there. And so break and continue can specify the loop or the switch. In case of a break, it can be specifying a switch. So that statement must be a labeled statement. So you can have statements, labels for the statements. There's no goto available, right? Normally a label is used with a goto. And in C language, and we have label and we say goto and use a label. And here label is to the loop statement. Switch, continue, right? They are applicable to a loop. Breaking the loop or continuing the next iteration of the loop. Fine, clear?
so obviously this label can also be applied to while, to while.
Yes, any loop statement. Fine. For, while, and do while. Fine. I've just illustrated with a for. Okay. Fine. So, okay. So next, let's see. Okay. Yeah. What other statements are there? So we have seen, I think, most commonly used things. Fine. We have the for flow control. It's normally the if. The loop statements are for, while, do while. Switch. That's again the conditional statement. And what other things? What other statements do we know about in C language? If else is, yeah, we have covered that earlier. And so we had all these things, right? So if else, if structure, then the switch case. Okay, and then we have the loop statements for, while, do while. Okay. Yeah. What other statements? Simple statements. Then we have a statement called return. So what is return for?
Returns the value of
Yeah.
output basically.
Okay. A return statement. See, it's applicable to a method, right?
Yes.
Okay. See, what happens when we are defining a method? How do we define a method? Okay, we might say public or not. Fine, that's one thing. Okay. It will be static or not. That's another. Okay. But then your method must have a, okay, even if I don't put public, I still can have a method, right? My method must have a return type. So return type can be, maybe let's say int. Okay. So we have some method with return type int. Let the method name be method. Okay, it will have parameters. Then it can have parameters. Maybe parameters are of type int again, a comma int b. Oh, it's more like that. Okay, fine. So if this is a method, yes, what can be done? You might have statements here, and yeah, you might have some if statement also. Oh, if this is the condition, oh, you might like to return a value. When we use a return, the return is applicable to the method. The return statement has to have a expression matching the return type, int type. Okay, in this case, int type, which is nothing but your, fine, it's the, fine, it's the return type, matching the return type.
What is like?
And at the end, again, yes, you must have a return for some int type. Right? This is nothing but your return type. So return statement, the expression following the return statement matches the return type of the method. The statement is used inside a method, return statement. So what is the idea of this return? What is the idea of the return? A method is like a function, right? Someone calls a method, so it's going to be used by someone. Someone will be saying, oh, I'm calling method 1. So when someone says method 1, he's supposed to be giving 2 values. Okay. So if someone calls this method, then what does it result into? He is expecting a value, right? Because the method has a return type of int, he is expecting it to give it at int, and maybe he might say int a equals this. Maybe he wants to store the int value returned by the method. Okay, he is expecting a value from it, right? This is what is expected. So gives 2 inputs, the processing happens, fine. In some case, maybe in between, you might say, okay, I'm giving this value, right? Otherwise, okay, I proceed further, do more processing maybe. So as soon as I can determine a value, which is the value for this method, I'll return it. And we return the value, right? Okay. So, fine. So A will get that value, right? Okay. So one is a statement called return. See, purpose of a method, do some processing, and some methods will have a return type other than void. That means they also have a value, right, associated with them. Okay, fine. There is a statement which is opposite of return. We have a statement called throw, and Java has a statement called throw, and this is opposite of return. Again, throw also is used inside a method, and okay, on some condition, maybe on like this, we have on a condition, we say, oh, we are returning a value, but oh, there's another condition where I would like to throw. Throwable type. I can't give you a value here. You have given me inputs. As I'm processing them, I find something wrong with this. I'm incapable of giving you a value back. I'm supposed to be giving you a value, but no, I can't. This is a method which says I want to divide. It's a divide method and integer division, right? Oh, you have not the second, the denominator is 0. No, I don't have an integer for this. So the one who is waiting for a int value, what happens to this? He's invoked the method. So a method, you come out of a method in two ways. A return means I have successfully finished my task and here is my value. A throw means this is unsuccessful. And you take up a task, you either succeed or you fail. When method is a task, when it's doing a task done successfully, he is going to return a value. Sometimes, no, I can't finish this. Okay, then throw it.
How do we determine where to use, like,
Wherever you feel there is an error, it's an error condition. I can't give you a value, right? This is to fail. You have to fail. You want to fail it. So, see, the operators are doing it for us. We have an operator called divide, right? Integer division. If you do an integer division here, okay, yeah. So instead of this, okay, equivalent of this may be something like this, right? Okay, something where he has done a slash b. Okay, a slash b. Now, when you do this, right, the slash is an operation for the int type. It will go there, fine. The code which is applicable to slash, yes, that's part of the, because it's an operator, it's part of the JVM. And it's part of the instruction set. But that instruction set is doing this. It's executing a throw. And this is throwing. This has failed. What has failed? The divide operator has failed. It has actually done a throw there. Otherwise, it was returning a value. It's not returning the value, but it's now throwing. Because it has thrown, what happens to this method? If a step here has failed, can it proceed further? There are some other steps. Can it go further? No. So a failure here is a failure of the method. There's no explicit throw which you can see here. But yeah, throw was inside that. Right? See this method being called from another method, right? Fine. So it's some main method saying, oh, I'm calling method. Main method says, I want to call the method called method. And it is supposed to be returning an int value, right? So wherever this code is, this is inside a method. Right? For that method, what this is a statement. There is a next statement. If this fails, can it proceed? No. What happens then? What happens to the method which is using this? That method also fails. No explicit throw, but there is a failure. So methods either succeed or fail. There are two ways to finish a method. Return indicates success and throw indicates a failure. That's how they are opposites.
and what we should write in throwable type?
We'll be looking at it later. I'm just mentioning what can be thrown or anything which is throwable, right? So there is a class called throwable.
Yes.
Okay.
Throws and
Yeah, throws is a different thing. Okay. What is throws? I can put it now also. What is throws? Yeah. Okay. Return is followed by what kind of expression? It has to match the expression which matches the return type. When you write a method, what do we indicate? What is the return type indicating?
Result should be
It is indicating that if I succeed, you will get a value of this type. So when you are writing a method, you're saying, okay, I have this method, I'm taking inputs, but you're also making a declaration. A success would mean you get a value of this type. Right? You're declaring about the success type, you can declare about the failure types by using throws. So it's a declaration. It's not an executable statement. See, return type is not an executable thing, right? It's just a declarative part. I could be saying, and some throwable type. Throwable type 1. No, I can have a failure of this type. If you use this method, be aware, you can get a failure of this type. Throwable represents a failure. You can have, so these are representing different types of failure conditions. Throwable is representing a different type of failure. So a method says, if I'm successful, you're declaring type will be int. I can be, so if you are using me, be aware, you can get a failure of this type or this type or this type. It's a list. Come on.
We just throw the only class or for package also.
We throw an object which is of type. And everything is object.
And what if like we don't return the statement?
Compilation error. If the return type other than void. If return type is void, return is not mandatory. Fine. If return type is void, a return statement in that method should not have an expression. That's it. You can use return. Fine. If there is something return, the return type was void, I can say just return. Okay. Fine. Success. Oh, my processing is over. Clear? The task. It's a task. Fine. The task has finished successfully. I'm returning. The task wants to fail. You have a account class. Fine. So it's a bank account. And someone says, I want to deposit minus 500. Would you allow that? You would say, oh, you get a failure if you do that. You would like to fail, right? The one who writes a method, he can check, oh, that input is not correct. I won't proceed. You will have a failure. It's not my fault. You gave me a wrong value. I'll not give you a value. Fine, I can't be doing that thing. Yes? So always your functions should initially be checking, right, what inputs are given to me. Right? See, it's all methods are just nothing but small tasks which can be done. Then we have a major task which may be using those smaller tasks. And a method may be using some other method, right? Okay. So each method is a purpose, right? Do some processing, right? Return type void, do a processing, give me a value, return type according to the type of value which it has to return. Okay, fine. Yeah, so throws, yeah. Anyway, we will be having a topic on what is exceptions, right? So, yeah.
So similarly, for the function, they should have given returns in method.
Yeah.
Like throws, they should have
Yeah,
given
yeah,
returns.
yeah. Throws has a fine method will only give one type of value. Yeah. Yeah. But yeah, this is from C basically. They inherited this from C, right? So when they put C languages, they put the return type should be mentioned first. Okay, then yes, any method will, so this is basic for a method. Then there will be different, oh, this has to be public, and what kind of things, or sometimes you like it to be static, sometimes some other kinds also. Okay, fine. Methods are nothing but operations, and small operations. Okay, and you have to create those operations, you have to define them, how the operation will be performed. Okay, and there are many aspects to this. As we proceed, yes, we will be coming across everything. Yeah. Okay, any other statements from C language, if you recollect, that can be discussed?
In C we have until.
No, C doesn't have until. Do while. C में नहीं है. Until is basic language or some yeah, Fortran or basic, they have. Pascal. Okay. So different words, but basically meaning is same. It's a fine while, we call it as do while. That is having until. Until is like the while of a do while.
Until is of course very confusing. So
Yeah, actually until would be a opposite in terms of the check, true false check. When we know that, right? While and do while, they both take Boolean. Okay, fine. While is followed by a Boolean expression, and that Boolean expression, if it is true, the iteration happens. As soon as it becomes false, the iteration, it comes out of the iteration. And that aspect everyone knows, right? From C language, we know that. Okay. 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 So yeah, and so statements, I think we're done with the statement part, at least the initial discussions. Other statements, new things, as they come to us, we'll take them, right? And yeah. Okay, so next what we should be looking at is defining our own type, and the first type we'll be defining will be classes, right? Okay, it's for defining data types, right? So we would create our own data types, right? Class is a data type. Yeah. Okay. So we have types from the language, like type int is there from the Java language, right? Okay, and then a programmer can create his own data types, date, right? Same way. Maybe we can start with some simple data type. Okay, fine. And so we may like to create a type called, so you might be interested in creating a type called rectangle. So fine. Next time what we'll be doing is we'll take the type called rectangle and defining a class. Okay. So the main idea of the class rectangle is about, okay, understand the various syntaxes, members, okay, okay, what are the members which can go in a class definition? That's the whole idea about taking up the class called rectangle. And so we should be able to see what kind of members go in a class definition, right? So if you define a class, right, we can, so class can have methods, that's one thing we have seen, right? we had a class, and hello world, we put a main method in that, or we put multiple methods in our case here, right? In the beginning we had done that. So yes, we'll see what kind of members go in a class definition. But just as an exercise, as an example, we'll use the rectangle class, and then you will be doing an exercise, okay, fine, which is about where you will be defining a class called account. So I'll be demonstrating with rectangle, and then I'll give you something about defining the class account. Okay, initial definition we'll have. Okay, fine. So that's the next part. So yeah, any questions? Because I think it's we may not be able to proceed much in the defining class. So we can keep it tomorrow only, as far as the class is concerned. But yes, for all of that we have seen so far, you want to discuss something, or you have your own questions? Any particular aspect you would like to discuss about?